Welcome back to our final session in Track A today, moving to a modern data architecture. Our next speaker is Nicholas Ngorok, who is an engineering manager at Twitch, and he is going to be talking to us about the topic of managing the unmanageable ETL. So with that, I will turn it over to you, Nicholas.
Great. Thanks, Frank. And I hope my slides are viewable right now.
Yes, they are.
Thanks. Hi, everyone. As Frank said, my name is Nicholas Ngorok. I'm an engineering manager for the data infrastructure team at Twitch. And today I'm going to talk to you about managing the unmanageable ETL. Whilst the title I picked is clickbaity, and I hope that was a draw to get you to attend, I'm really just going to be talking about the journey of how we empowered analysts at Twitch to build better aggregates and in turn do ETL themselves rather than rely on data engineering teams or other engineers at the company. But to get us started off, I hope everyone knows what Twitch is, but in case you don't, Twitch is where millions of people come together live every day to chat, interact, and make their own entertainment. The really compelling thing about Twitch is the great community that creators are able to engage with, doing things from playing video games, music, talk shows, wood carving, cooking on streams, food and drink, etc. Like the fact that as a creator, you're able to interact with your audience whilst you're streaming and just have that sense of community is really a compelling thing that draws people to using Twitch. What this looks like from a numbers perspective. So looking at last year, we had 1 trillion minutes watched on Twitch by an average of 30 million daily visitors to our website, and over 7 million unique streamers go live every month. What this results in is, as you can imagine, an enormous amount of data coming into our systems that we then would need to analyze to determine what sort of investments we should make in the business. Now, the team I manage, the data infrastructure team, we're really develop and operate Twitch's data platform. Here are some examples of the technologies we use, although we use more technologies than are listed here. You can see Redshift, S3, Kinesis, Spark, Airflow, which is really going to be something I talk a lot about in this presentation, which is a platform to programmatically author, schedule, and monitor your workflows. The scale that we're operating at right now is we receive about 80 billion events per day coming into a pipeline, and we focus on building tools that help us ingest, store, transform, and basically just move this data for usage at Twitch. So in this talk, I'm really going to go over 4 areas. We'll start by covering what the problem space is, talk about the version 1 of a solution that we built, and the challenges we faced there that led us to build the version 2, and then cover sort of like the lessons we've learned going through this journey. So let's start off talking about the problem space that we're in. So at the heart of this, you want to do data analysis. You've got a bunch of unstructured data and business reporting and analysis you'd like to do to get insights from your data to make business decisions. This is where you tend to hire an analyst who sits in the middle, has a very good understanding of what your data is, probably writes a bunch of SQL and queries to then generate reports, which they share with stakeholders who make business decisions at your company. So when the amount of data is quite small, you would have like a small team of analysts who really understand what all this data is and are able to generate the insights. However, when you scale up, you start to run into a couple of challenges. For instance, there is a scaling limit with how many analysts you can hire, just because when you have more data, it's just impossible for like a few group of people to know what all the data is. But also as you're scaling, you have more people that want more insights because the business is growing in all areas and everyone would like to make data-driven decisions for the company. And the primary reason that makes this a challenge is that you're having more data in your system. So queries that you previously run are taking even longer because they're being run over a larger amount of data. And so that whole cycle takes a long time to actually get you your eventual insights that you'd like. So a quick look into what our event ingestion is like at Twitch. I choose data warehouse / data lake because this is how our ingestion has evolved over the past 7 or so years. So we have folks watching Twitch on mobile, web, console, and different clients, and those clients send events to us. We have a cluster of servers that we call Edge, which receive all these events, and a processor will then transform them. When we used our data warehouse, which was a large Redshift cluster shared by the entire company, we converted to TSV and loaded it into our cluster. But now that we use a data lake, which is a big S3 bucket, and use Redshift Spectrum to actually query it, we actually convert our data into Parquet files, which we store in our data lake. Now, the translation of the scaling challenges I talked about that we see as a company is we've got thousands of raw events coming in. And as I talked about, like your small team of analysts or whatever size of analysts just cannot know what every single event is. So you have a distributed knowledge of it. Your data size is pretty large. And so basically running queries takes a really long time. And most analysis actually care about an aggregate of the raw events to actually generate useful insights. And so most queries are some kind of join. And just to give you perspective in like how expensive it is to calculate aggregates, you can imagine a query to calculate an aggregate you care about taking an hour to run for a day. And so if you wanted to generate a report for a specific aggregate that had data for the past month, then you need to run that query for the past, say, 30 days, which results in 30 hours of running the query. And is just not really a scalable solution to generate business reports and insights as quickly as possible. Tie that in with, we kept growing as a company, business was doing well, and there was an increased desire for more analysis from different parts of the business. And we were not in a great situation to actually get data out to folks as quickly as we could. This then led us to come up with the first solution of what could we do to make aggregates better for the company. And it was a system that we called Rollup. And this is a high-level architecture of what we used. So what we had analysts do is write the SQL for the aggregate they cared about in a Git repo, merge it, it gets built in Jenkins, and then deployed to our Airflow server. And then our Airflow would run on a nightly basis and actually run the SQL in our Redshift cluster. So the way this works, it would create a temporary table and then select the bounds for the query, which would be like, if we're running today and we're running a query of yesterday's data, then midnight today would be the end date and midnight yesterday would be the start date. And so we'd actually be able to run the query for yesterday's data. And then those results would be inserted into the temporary table and then merged into the rollup table that everyone has access to. And then you commit and run analyze in your Redshift cluster. We also provided a Python script, Python backfill script, which would let analysts trigger runs of all their dates since before they actually merged in their changes, or run backfills to correct data. So this was theoretically well and good, but we really run into a major issue that is very well captured by this XKCD image. And that is that we asked analysts to really do things that engineers tend to do. They needed to use Git, they needed to use Python, they should know a little bit about Jenkins to actually use this flow. And the barrier to entry was incredibly difficult for them, just because it was a very different skill set than they use in their day-to-day. We tried to circumvent this by having a lot of documentation that really specified, like, here's every step you need to go through. Here's some major issues we've seen people run into, and here's how you can solve them. And that worked well if folks followed every instruction to the letter and things went well. But if they didn't, they would basically get stuck and have to ping someone in my team to help them debug, just because it was very far from their day-to-day work, and they weren't going to be able to figure out what the issue was. The other challenges that this solution had was that it required a coordinated effort between analysts and my team the first time they were deploying any changes they cared about, just because my team had admin access to the Redshift cluster and they didn't. So the first time they created a rollup, they would want a rollup table in a Redshift cluster, and my team had to do that for them. The other biggest pain point of this system was that it only allowed you to create like base level aggregates. So like the first aggregate, but you can imagine that what people really need is aggregates of aggregates, or aggregates of aggregates of aggregates. Like that chain can keep going. But that was a compelling reason that analysts wanted an even better system for us. So this led us towards building a version 2 of this system, which is a system we designed called Sheik. As we built Sheik, we took into consideration all the different lessons that we had learned from the rollup system. And what Sheik is it's a Django web application that's used to create data cubes, and a data cube is essentially an aggregate. And what Sheik does is it runs the SQL on a specified interval, which can be weekly, daily, annually, or monthly, and stores the results in our data lake. And really the core value that Sheik gives compared to rollups is the dependency management between cubes. So this would allow you to do aggregates and aggregates of aggregates and aggregates of aggregates of aggregates while specifying dependencies of how they work together. And I think the best part for our analysts is that it is very UI driven. So they don't need to learn how to use CLIs. They no longer need to know about Git and what commands. And basically the ramp up period for any new analyst joining the organization and just trying to build analysis for their stakeholders is a lot less than it previously was. So let's quickly go through some screenshots of what Sheik looks like for analysts in their day-to-day usage at the company. So here's a screenshot of what it looks like when you created a table. So we've got user A that created a user A SQL table. And the first part is when you create a table, you specify what's this table about in your description, because Sheik is basically a central system that all analysts and other people at the company would have access to. So this information is public to everyone. And so you describe what your cube does. We keep track of who actually created the cube in case folks need to reach out to you because of issues they're saying. And then actually specifying the table that it's stored in our data lake. In this example, it's cubes.user a SQL. And then when you're creating a cube, as I said previously, you can specify the schedule of how often you'd like Sheik to run it. And so in this example, we're asking Sheik to run this cube on a daily basis. And so every day it will run and the results will be stored in our data lake, and we will have all the history for this cube for all the days that it's run. When you create your cube, you actually then specify the SQL that you'd like to be run on the schedule that you've specified. Here's a simple SQL in this example. One thing I would highlight is that we have variables start day and end day that users specify within their SQL, and Sheik would actually fill this in with the appropriate days. So like in the example I talked about previously, if we were running on a daily schedule, if we're running for yesterday's today, end date would be midnight of today and start date would be midnight of yesterday. So that Sheik actually just gets the, so that Sheik basically just gets the results of yesterday when it runs. So let's look at another table. Similarly, we've got so this is a table created by user B, has the similar type descriptions and the SQL, but this table is actually dependent on the user A table that I showed you previously. And as you can see, the dependency is in the SQL that's written, and Sheik is able to determine this is a dependency to another cube that was created in the system and keep track of them and ensure that for whatever day we would like to run, whether it's a backfill or a daily schedule of user B SQL table, user A SQL table for that day must have run first before user B, and so that we would manage our dependencies well. Now, while the example I've shown you here is quite simplified, the reality is, like in our production systems, we have lots of cubes which are dependent of tens of other cubes, and we end up having this massive graph of dependencies for our cubes. Other features we have, so the activity page shows you what backfills and runs have happened for your cube. And you can go in here and actually see the history. You can also see the current status of any backfills that you're currently running. And you have the ability to schedule a manual backfill in the UI, which you can use to either load past data for your cube or to correct incorrect data that you've discovered. This page also shows you if there are any downstream tables. So like if you remember in the previous slide, user B SQL was using user A, and so was dependent on user A. But from user A's perspective, user B SQL table is its downstream. And if we were looking at the activity page of user B SQL, we would actually see that user A SQL would be its upstream. And any tables that are in the middle could have multiple upstreams and multiple downstreams, which would be displayed in this page. The other feature that we provide is a diffing mechanism. So in this example, we can look at different versions of the SQL that existed for a cube and see what changes happened. This is very good to help our analysts debugging changes they've previously made by looking at the history. Some additional features that Sheik provides is we have a concept of QA cubes, which are distinct from the rest of the ecosystem that can be created and backfilled, and the data safely verified that it works appropriately before being added to the cubes that everyone has access to as a company. We also have email updates that folks can sign up to for cubes that they care about. And this, for example, is get updates if your cube successfully run, or get updates if there was a failure running your cube, etc. And lastly, we have the ability to hide cubes if they don't have any dependencies. Once they have dependencies, then they're important to everyone else that is using Sheik. But if they don't, and you'd like to work on your cube without other people knowing about it, you can actually hide it in our interface. So from an architectural standpoint, here's what Sheik looks like. Our UI is TypeScript and React. The backend is a Django application, and we use an RDS Postgres instance for our database. Our database tracks the state of all the cubes and takes care of a bunch of the dependency management. And then Airflow runs the scripts, runs the SQL on the schedule that we specify. The way this works is that Airflow will run the query on Redshift, which will use Redshift Spectrum to actually query against our data lake. The results are unloaded into an S3 bucket. And then Airflow will trigger our data lake API to tell it to copy the unloaded data from the S3 bucket to our data lake, such that it's accessible to people at the company as well as future runs of Sheik, so dependency cubes down in the chain, we'll actually be able to access it from our data lake, and then it updates the state in Sheik via an API that Sheik has, so that it will update the state within its database. Airflow is really at the heart of how Sheik operates, and I just want to go into a bit more detail of how we use it, because it differs quite a bit from how people often use Airflow. So something we realized as we were trying to work with Airflow and building out Sheik was that it doesn't handle dynamic dependencies, and we had extremely large DAGs that weren't working well with Airflow's UI. And so we had to actually design our dependency management within Sheik and store all of it in our database and track it. Airflow works with static set of DAGs, but Sheik has dynamic set of DAGs. And you can imagine that because it's an ever evolving set of cubes. Users are creating and editing cubes. And you can imagine that changes the dependency chains that are running. And so that needs to be regularly updated. And so how we made this work is keep track of all of this in our database, have an endpoint that Sheik provides, and then Airflow every minute hits this endpoint to download a JSON file with the most up-to-date DAGs that it should run, and then it actually executes that. So let's finish off with what are the lessons we've learned going through this experience. And before I get into this, I think the first thing I'd like to show you all is just what usage of Sheik at the company has been like the past couple of years. So the Rollups system, which was Aggregates V1 that I talked about, only had about 72 rollups because of all the challenges I talked about. High barrier to entry, just like analysts don't like working with Git or doing engineering things. But when we moved over to Sheik, you can see an exponential increase in the number of cubes we've had in the company. And now we're in the thousands of cubes that are actively being used. Things went way better than we were expecting when we created the system, and we're very happy about that. But this also means we're operating at a scale that we did not think we would. And so now we have a couple of challenges related to scale that we need to figure out. But through this journey, some of the lessons we've learned that I would highlight is one important thing is factoring your user skill set in your solution choice is really important. If you look at our version 1, we took the easy route. Just create a system with simple components that you can get out quick to support the use case. But if we considered that analysts wouldn't be as good using the tools that we created and focused on that, we perhaps would have built a UI from the get-go. But at the heart of this, there's a trade-off that you have to make as a company when you're building it. Do you need a solution to come out really quickly? Because version 1 was a lot easier to build than version 2, which is Sheik, just because we've got this UI, we have to design and build it, and we have a complicated backend managing dependencies that we also had to build. Something we've also learned the hard way as we've seen increased use of Sheik at the company is that we need to limit user control because it's a shared space, and a bad actor can affect everyone else. So like if you have a cube that runs for a really long time, let's say 5 hours, and it has a lot of downstreams that are dependent on it, every one of those downstreams would get blocked until that completes, and that could lead to really long, let's say, daily runtimes. So as an example, to give you a sense of the scale we're operating at, our current daily runs every day take about 8 hours to run because of all the cubes we have and all the different dependencies that are happening. The other thing that ended up happening, and we've learned, is like you really can't completely predict how people will use your systems. So like when we created Sheik, we expected analysts to use it, and they have, but it's been it's been a really great system that we found other folks at the company, so other data scientists, applied scientists, and even other engineering teams have started using Sheik to power product use cases at the company. We've got machine learning teams where applied scientists might actually develop the feature sets in Sheik, output into our data lake, and then they're consumed later for building their pipelines. And what this is actually bringing to life for us now is that we didn't build the system with that in mind. And now, because it's being used for these use cases, we need to figure out a way to make it more reliable, have better latency, because product solutions have more stringent constraints than analysts just trying to run analysis to generate business reports. So what is next for us based on the things I've talked about? As I mentioned before, like the usage has really been up and to the right, really blown us away. But now we need to figure out how to scale this system even more. Whilst our daily runs take 8 hours to run, it'd be better if they took shorter. The things we've already done are we've figured out how to scale horizontally, so we can actually get Sheik to direct queries. It's running for cubes to multiple Redshift clusters simultaneously, and that allows us to parallelize how many cubes we can run at the same time and not have Redshift as a restriction. However, we've sort of hit the limit on what that is, because your dependency chain becomes your blocking factor. And we need to figure out a way to, say, scale horizontally, such that cubes with SQL that's taking a really long time to run can probably run in a shorter amount of time. But this is something we're trying to figure out how best to scale as we continue to have more and more cubes come into our system. And also having other engineers coming into usage of Sheik. A request we've also gotten is for external dependency management. So we have teams that will get their RDS tables and DynamoDB tables ingested into our data lake and then build cubes off of those. But they would like those cubes to only start running once, say, like the daily ingestion of that table has happened. And likewise, they might want to have some system that the completion of a Sheik cube run triggers and they do something else in the rest of their pipeline. And so this is something we didn't initially consider, but we're going to be looking into how to build so that we can empower even further use cases of this at the company. And that's it. Thanks all for coming and listening to my talk.
Great, Nicholas. Thank you very much. This was very informative. We had one question related to the link to Sheik, but I think that was addressed as it's in your presentation. So one of the questions that I had was in regard to now all of the data cubes that you have, has there been a discussion from the data governance side on how to manage all of that? And I'm thinking mainly in respect to questions about the reliability and validity of all of the cubes that are being created. Are they being created such that the data that's coming out is actually accurate, and the traditional kind of stuff?
Yeah, no, that's a very good question. I think it's definitely, I'd say, like data quality and governance are issues that I think anyone in any data team, right, is continuously facing and trying to figure out what to do. What we've seen so far as Sheik is considered is different things have come into play. For instance, we have this intermediate schema that's been created at a company to have baseline cubes that everyone else uses in building their cubes. And so these baseline cubes are, we deem them as blessed. So like cubes that we know are legitimate and you can trust the data that's in those, and feel free to build it off of those.
Okay.
So like that's one of the things we've we've put in place to have this better. From a more ad hoc perspective, what often tends to happen is because we actually have the ownership information of who owns what cube, folks can actually follow up with them in case they're seeing any discrepancies. In the future, we're thinking about like, also, is there any sort of testing we could add at sort of like the end of the pipeline to actually maybe do like a sampling of the data and make sure that it looks correct based on certain expectations specified for a cube. But that's something you're thinking about building in the future.
Oh, okay, great. That's fascinating. Will you be able to join us in the networking lounge in Feed Loop
Yes.
for a little bit? Okay, great.
Good.
All right. I think that there are there don't appear to be any more questions in the chat, but I think that's because oftentimes people prefer to ask them in the networking room. So thanks again, Nicholas. This is really fascinating, especially in terms of, I know that we've had some of the same issues related to Git. So yeah, that was very interesting.
Yeah, when you know Git, you're like, just use Git. But
yeah,
if you don't, it's a bit of a challenge, isn't it?
Yes, that is true. So for all of you, our networking lounge is in Feedloop. If you go over to the left-hand menu bar, there's a link called networking, and then there's a tab for groups, and then just go into the link for track A, and that's where the conversation will start. And then we have the final session of the day up at the top of the hour, and that will be our final keynote. So again, thanks, Nicholas. This is really great.
Thank you. And thanks everyone for attending.